I mean, it's just a cold, but I think. I don't think I'll die. But anyway, if our time wasn't limited, I would not be here. I feel like crap. This is my third day of not running, so when I don't run for 3 days, you know something. I'm shaking so much I can't even get my mouse.
All that
What is it?
energy.
So,
22nd?
yeah, 27, yeah. Yeah, we'll do what we can, and if I collapse, just push me to the side.
What's the number again?
Oh, man, I forgot you.
For the infirmary?
Yeah. Yeah.
No, I'm looking at.
911.
What's the number now?
Yeah. Oh my goodness, seriously, I'll just sit in my room by the heater after this. No, I think we're right though. I'm just whipped from the first 2 classes. Let's see. Cody, I thought I had to ask you a question. Oh, what do you have? You have something from 9:30 to 10:45, right? Okay. So yeah, we'll do you. We'll schedule you sometime, not next week, but the week after, and then you two will just do it here. So okay. Preliminary. So what we're going to do is this: perform concept analysis and really perform a problem analysis. But this will really be our only problem. Hope you had fun with that problem. You know, and I know, no, you didn't. And here's probably the hardest thing to get used to when it comes to a problem or even a concept. You know, at a young age, and not necessarily you're young, you are young, but at a young stage in your teaching development, it's really easy and perfectly fine and understandable to get your concept, solve your problem, be done, and turn, shut your butt and go on. But as teachers, I think we need to analyze things a little bit more because students are going to ask us stuff, and we need to know the little nuances of a problem, the mistakes they're going to make, and why this problem is different than that problem. I mean, if you really think about it, from a reading level perspective, problem number 1 and problem 2, exact same, right? But it wasn't, the same at all. So we will look at that in a second, and then in the end, we're going to hopefully be able to explain the concept of perfect square numbers. Yeah. So first thing is, I forgot to ask this last Thursday, is, well, actually, if you look at the essential questions, because I do like my first essential question, and really the second one too, but the first one is interesting because they have never, looked at it this way. But what is the difference between finding the average speed of 2 situations? So think about that problem. The average speed of 2 situations when the time is the same versus when the distances are the same. That's the question we want to answer, because if you think about it, I don't know. And if somebody just asked you that without even giving you a problem, of course now you're corrupted by the problem itself, but if somebody just asked you that question, how would you maybe think about that? But hold on to that for a second before we get to the problem there. And then why are perfect square numbers called that? So then syllabus, any questions on syllabus? Can you give me that sign page then?
You want to sign them pen?
No. Oh, yeah, they did that right.
I'm reading.
No, I know, that's what I mean. You were actually, I should have asked you to. Okay. So 3 axioms of teaching are what? Know your crap. No. Second one is what? You can't just know your crap. No more than your crap. And teach from the overflow of knowledge. Okay. If you just had to give me a 1-sentence summary of, you're taking a class on pedagogical content knowledge. Somebody says, "The heck is pedagogical content knowledge?" What would you say to them? What are you learning? What are you supposed to learn?
How to be a professional teacher.
Okay, more than that. That's true though. Pedagogical content knowledge. What would you say?
Like knowing the meaning behind what you're teaching, but more in depth.
Okay, maybe knowing the meaning behind your teaching, or behind what you're teaching, and more in depth. But I want somebody to add, so you can what though? Because the word's pedagogical.
Teach more fast.
Right. So you can teach it more effectively. So it's really about knowing your specific content and knowing pedagogical strategies and how that knowledge of your content affects the pedagogy. Because if I only know, and we all reach this limit in their mathematical knowledge. So if the only thing I know is how to find the derivative of a function using the product rule, I'm probably not going, and I don't, let me finish that sentence, and I don't understand what the derivative itself actually means, or why that product rule works, or how areas that students are going to have problems with when I'm thinking about that, mistakes they're going to make when I am having them do a problem with derivatives. If I only know that, I'm probably not going to be a very effective teacher. I'm just going to stand up there and tell them how to do something, and I'm not going to be able to talk about the concepts. So it's about knowing a little bit more than just your content. It's how the content affects pedagogy. So for instance, you've already delved into this problem, so we might say, and I don't want it to become a memorization thing, because if I leave this problem by telling my students to just memorize this, when you're finding the average average rate and the times are the same, then do this. And when you're asked to find the average rate when the distances are the same, then do this. You're not gonna remember it. You're gonna say, yes, I get it. I'll do all right for the problems in the class. Right before the test, in a week and a half, I will memorize it again, and you'll ask, but I'm not gonna really understand it, okay? Yeah, so, and then advanced perspective, when you say we're looking at something from an advanced perspective, like what does that mean to you? Looking for something from an advanced perspective. And you can cheat. You can cheat by looking, think about it here on page 16. Look, not just surface level. Take into account the connections, representations. How's this related to this over here? Is there a relation? I mean, pretty much math is all somehow intertwined. Okay, it doesn't necessarily mean that every little concept here relates to every little concept here, but for the most part, things are intertwined. Deep analysis, and then thinking about some of the history, like how do we used to do this, and how did that affect what we do today? Even just, you remember from history of math, we talked about the cubic equations. Thinking about the first cubic equations, or even quadratic ones really, were solved based on how they looked. So if it was ax cubed plus bx equals c, I solved that with a different method than I did if it was ax cubed plus bx plus c equals 0. Now, same thing with like quadratics and that. Now, we have one formula. I guess you could still say the same thing, but we have one formula and you just have to put it in the right form in order to use that formula. You can't use the quadratic formula. I'm gonna lie here, ready? You can't use the quadratic formula if the problem looks like, let's see how long I can stand this. If a student tried to solve that right there, you're gonna say something. And they try to solve it by just putting, I guess let's do it. Give me actual answers here, right? Numbers. And they said A is 3, B is 5, and C is 7. First thing out of your mouth is gonna be what? No, you can't do it. You gotta put it in the right form, right? It's gotta be 3x squared plus 5x minus 7. You're gonna start salivating, right? 3x squared plus 5x minus 7 equals 0. You just gotta remember that. It's gotta be in that form before you use the quadratic formula. Baloney. Hopefully this class is starting you to think about, if you want to put everything like that, fine. Just make up your own quadratic formula, right? So everywhere C is in the quadratic formula, put a negative C, right? Put the opposite. Who cares? So what do you got? Opposite of B, plus or minus the square root of b squared minus, just make it plus 4ac. Isn't that right? Wouldn't that be? Well, I'd rather add than subtract anyway, dang it, right? Of course, b could be negative and you might be right. But still, the point is, let's not think that all this crap is so rigid that we can't make some stuff up as you go. So, all right. So let's look at that problem. What's the answer to the first one?
50.
Wrong? No, just kidding. So that's 50. And what's the answer to the second one?
48.
Everybody get that? Did you get that, Ashley? Did you get 48 for the second one? No? What'd you get? I want you to get the wrong answers.
We got 50.
So it's okay.
Jess and I worked on together.
Yeah.
And for the first one, we got 66.6
Ooh. Wait.
repeats.
Wait, how can the average be higher?
Oh.
Oh, didn't think about that one, did you? Go back and check. No, and listen. It's okay. It's okay. I want you to. I want you to get all the problems right. I want you to know everything. But I am a realist, and I know you're not going to. Did you get 50 and 48?
Yeah, we were.
Yeah.
We were.
Oh, you guys worked together. Okay.
I did not use
Team
it
one
like
and
that.
team two.
I did not use that in like
So maybe we should switch.
a formula standpoint though, and I wasn't thinking it equals RT.
Oh, okay. Well, we'll talk about. Let's go ahead and talk about that. But I guess my first question or my first point is this: is that again, it's okay to get the wrong answer. Okay, because most of the problems in PCK are worded in such a way that if you're not super in tune with thinking about it, that it's not going to make sense. But I will say this: so the answer to the first one is 50. And 50 is just the average of 60 and 40, isn't it? 60
Yeah.
is, yeah.
We thought that you had to change, since it was in miles per hour, we thought that you had to change 45 minutes into how many hours?
Okay, so but let's do it. So actually, I want to see, and one of you can just get up there. Let's see how you actually went about, because that's fine. I mean, that's how I did it, I guess.
So
Oh,
you
you
guys.
already
What-
said it.
Well, what did you write? Go ahead and show us what you wrote down.
So you changed the time from 45 minutes to 60? Or
Well, we changed it because we did 60.
We'll just change it to 3/4 of an hour, right?
Yeah.
Yeah.
We did
That's what they
60
mean, because it's miles per hour.
And then
Yeah.
0.75 hours, and then we added it with the 40 miles. And then that was also 0.75.
Now, I want to stop right there for a second, though, because remember this. If you are, from a pedagogical standpoint, if you are going to read this problem, and I'm not saying you're wrong, I'm saying that if you're going to read this problem and you're going to write that up on the board, there better be some explanation as to why I am adding those two. Otherwise, think about the pedagogical implications. You are implying that the students are supposed to memorize that with this type of a problem, you would add, right?
Yeah.
So,
Well, it also
and
says
that's fine.
And in the problem, so that's where we go.
Okay, and then, so what we're doing is we're adding, and so you might say this, 60 miles over 0.75 hours is what? Like, I mean, what does that represent? I don't mean what the number is. Well, hey, if you want to write numbers, go ahead and tell me what you did after that.
Oh, okay, well then
Maybe I'll just ask
we figured
them.
it out to be 133.3 repeating. So we got some long decimals. And then we did that to,
The sum of those two is.
Yeah, the sum of those, and then divide by 2 for the average because of the 2 here. And then we
Right,
got
okay.
66.
Okay, so now back to the question. You have, oh, wait a second. You have 60 miles, but that's 60 miles per hour.
Oh,
Oh, you know what? That is, because, all right, above that, right, D equals RT. Just above somewhere, yeah, D equals RT. I mean, most people would think, even though you said you didn't, we'll get to that later, but.
Yeah, I thought about it.
I don't remember
As I looked in class, I was like, oh crap, dirt.
Oh, well, yeah, but my point is,
Yes.
because most people, would think this, but let's see, yeah, because the 60 miles per hour is actually R, right? And when you do 60 miles over 0.75 hours, that's actually the R, isn't it?
Yeah,
but that's not right,
It's
right?
actually 45 miles because you're going.
Right, so,
60 miles per
so,
hour.
but let's change that. Go ahead and actually change miles, where you have 60 miles,
Yeah.
write 60 mph. And same thing with 40 then, right? And now get rid of your 133.3, I guess. Does that make sense? I'm not sure where I'm going with this, but okay. So now let's talk about this. You have miles per hour over hours. Okay.
Yes.
Now that's
Wait, we're not very rate.
that is what? That is your rate divided by time, and that's nothing,
Yeah.
right? So what would you have to do with those numbers instead of divide them? If you want to get the distances, right? If you multiplied them, you would get the distance. Correct?
But
Do you know what I'm saying?
we're looking for.
If you took
One.
If you took 60 times, yeah, right. If you multiplied 60 times 0.75, you will get the distance.
Yeah.
So, I guess what I'm saying is miles per hour over hours isn't giving you anything, is it? You know what I'm saying? I mean,
Yeah.
with the
No,
problem,
yeah, not for
what are
that.
you saying? Miles per hour divided by hour, right?
Would that be miles per
What-
hour, so many hours squared?
Right. So now we're I mean now we're meaningless. We're meaningless in the realm of this problem. Miles per hour squared, right? Like that. Now we're talking gravity, right?
I don't know. What
9.9 meters per second squared.
So,
Yeah. So
That's the tricky part because I feel like a lot of students would see 60 mph and they're assuming like if they were trying to do that it'd be a numerator, but in like reality miles per hour is like miles over hour.
right.
So that's how we
that's
did that,
good.
was miles over hour. But
Yeah.
we did
Yeah, that's what
Okay. So now, I mean,
and
and our chemistry person here is better at this than us because
I had to deal with unit analysis.
because he does unit analysis more, right? But we have to make sure that, so pedagogically, that's a good point, Ryan said. Miles per hour, wait, that's miles over hour. So those hours do not cancel. And you
Yeah,
you see what I'm saying?
You'd be getting
So-
hours squared on the bottom.
Yeah.
Yeah, so when you actually do say 60 divided by 0.75, you get 80, but
Which is-
it's not 80 miles. It's 80 miles per hour squared, and that doesn't do me any good. Okay? So, but look at your D equals RT.
Yeah.
If you want the distance, and what do you, well, okay, let me go back here. If you want to find the average rate, what do? If you need to find the average rate that you drove someplace, what do? You're driving home. And how do you want to know the average speed that you went home? What would you do? Think about your formula there. Distance equals rate times time. You want to find your average rate.
Well, you divide it by the time.
You would take what?
Distance.
The distance. It's 30 miles home. The time in hours then, if I want to know miles per hour, right?
Yeah.
How much time it takes. I do that. And that is my miles per hour on average. Okay, got it? All right. But now I've gone this one place and then another place. So to find this place, you went distance over rate. Okay, or did I say that right? Distance.
Are you supposed to go back, revert in this problem, or are you talking about another problem?
No, I'm just trying to say, and I'm just trying to say in general, if you want to find your average rate. So here, because now I want to find my average rate for a two drive situation. I still need to know what? My entire distance, right? And then divide that by my entire time. I mean, nothing changes there. I still have to find. So beside distance equals rate times time, let's write this. R sub average. So R sub A. Sub A, yeah, because that'll stand for our average distance. So R sub A equals D, let's say D sub T, because that'll be D total.
Oh, wait, should I do capital T?
That doesn't matter. Over T sub T. So total time. Okay, now, are you ready?
Yeah.
Your distance you just added together, right? Add the distances together. That's your total distance.
Yeah, but you have to find it.
Well, right. But time, you just add your times together, right?
So we have.
Now, you don't add the averages together.
No.
because it's an average, right? And it's the average rate of speed, which means it's already divided by however many. It's R. So don't make this mistake. Don't say that dt is d1 plus d2. tt is t1 plus t2, and ra is r1 plus r2. That's not right. You know what I'm saying? Because how do you find rate, right? You just divide distance by time.
Yeah.
Okay, well, how do you find, you have distance equals rate times time. How do you find your distance that you travel if you traveled 45 minutes at 60 miles an hour?
So your rates every time.
Right? Distance equals rate times time. So for 60, you have 60 over 0.75. That needs to be 60 times
Yeah.
0.75. So underneath that, right, 60 miles per hour. And then times 0.75 hours. Now, I'm gonna have you do one more thing because of what Ryan said here. Many students will think that's gonna give you miles per hour squared, right?
Yeah.
So let's do this. Let's just for us right here, let's just change 60 miles per hour to 60 m over 1h, right? Because that's what miles per hour means.
Yeah.
Now, do you see that the hours cancel?
Yeah.
Okay, so that then gives you 45. So, and 45, so put equals 45.
That's your first distance.
That's 45. Now, that is, what, 45? Get your units right. You can't offend Ryan in here.
Sorry.
Miles.
45 miles, can't offend our science major. 40 miles, and that equals the first distance, distance 1, right? That equals D1.
Well, I mean, from a scientific standpoint, we have point. Oh no, we want it. Never mind. I'm wrong.
Now find your second, find D2 the same way. What would D2 be?
Make 40
Mhm.
miles
30 miles.
over 1 hour times 0.75 hours.
And I'll tell you that's 30.
Okay.
All right, now, based on your equation up there, R average equals DT over TT. Figure out your average rate.
DT over T.
So what's DT?
Would be these two added together.
Right? So RA equals, and I want you to write down 45 plus 30. 45 plus 30 equals and TT. What do you got? Look at your problem. What's your TTs? But it's T1 plus T2, so what do I write? What are your times? What's time 1?
Your time 1 would be 0.75.
Yep. And what's time 2?
0.75.
Yeah. So 0.75 times 0.75.
Plus.
Yeah, what'd I say?
You just said time. Too.
Listen, anything that comes out of my mouth today, not true, false, nothing. Just ignore it all. Don't even watch the video. So yeah, just write 0.75 plus 0.75. Oh, okay. Well, yeah, well, that's fine. That's fine. Now, if you do that, then you're gonna get 50. So just put equals 50.
Yes.
Now here. Now you can have C.
Okay.
And you might want to copy that down.
Yeah.
Okay. But now, what I want to do is this. From a pedagogical perspective, some smart aleck kid is going to say, oh, I did that a much easier way. I just added up 60 and 40, divided by 2, it's average, right? And it's 50, so there it is. And the unknowing teacher says, very brilliant, that's a good way of doing it. Let's move on. And then the question, then they didn't do their homework.
Why?
They didn't do the homework that they assigned for homework, because then that homework is number 2.
Yeah.
And the kid says, I didn't work that time. Something's wrong there. So I would never want to just leave that problem and say, when you have a problem, that is average rate, and you know that the distances are equal, then all you have to do is add them up and divide by. The question is, can you prove why that works? You know, did you prove that? Go ahead and show us what you did. Did you prove that? I mean, you could.
I just, my reasoning for it is, the only, like,
And we might be able to do it from some logical standpoint too, but then we are
Yeah.
math people that have gone through some proof classes, so we ought to be able to prove it too. Go ahead, what was your reasoning?
the reason that the 60 plus 40 and then divided by 2 works is because they're both equivalent times. So we said they were like weighted the same, essentially. But
from your, we originally, I
like
didn't
you
see
can't
that.
do that. Well, you can do that with the other one, but it takes a little more thinking.
Well, but
about
wait a
than
second,
just
though.
dividing by 2.
I mean, I guess in a way, from a pedagogical standpoint, I have a little bit of a problem unless we can clearly explain it to where everybody can understand it. When you say, because the times are weighted the same, why can't I use that same argument for when the distances are weighted the same in the second one? So why can't I do that?
Well, looking at it now,
Because
it makes a lot more
distance is
sense using your
affected by
formula
time.
because whenever, for problem 1 then, your t would be 1, so that if you had 60 miles an hour.
Oh, gotcha, okay.
And 40 miles an hour, like the smart aleck kid would probably just have done. Unknowingly, he'd say, oh, 60 plus 40 on 100, which would be our DT, divided by 2,
Okay.
which is conveniently our TT.
Okay, so,
2 is.
wait, let's listen, because this is probably a good way to maybe start the argument. I don't know that we'll completely get there, but let's understand what Ryan is saying. So if the speeds were actually the same, and I just rolled for 45 minutes at 60 miles an hour, kept on rolling for 45 minutes for 60 hours, just think about that logically for a second. You know, you never stopped, right? You never stopped, and you just kept going the same 60 mile an hour. So of course your average speed is just 60, which is 60 divided by, or 60 plus 60 divided by 2, right? Now, from a logical standpoint, how are you going to get there other than saying, well, because the times are equal and memorizing, but how are we going to get to, I'm not saying we can't, I'm just trying to have a hard time seeing where I can convince everybody. And it's hard sometimes because I've looked at this problem many times, right? And to me it's like, well, of course I can because I'm going to do something up there pretty soon. But if I went 60 mile an hour for 45 minutes, and then 40 mile an hour for 45 minutes,
You're doing the
how do I know that that would just be adding the 2 rates and dividing by 2?
instead of
Because I'm not going the same distances.
like instead of thinking it of 45 minutes as 0.75 hours, you could consider them as 1 unit of 45 minutes.
So,
Instead,
okay, so,
the denominator just becomes 1.
okay, but I really want to be general about it, but you go ahead though. What were you going to say?
Well, I think I mean, it doesn't follow the pattern of the problem, but I believe that the kid that would do it would originally. But what the kid would do would be, you do 60 plus 40, right? You have 100.
Yeah.
And his T1 and T2 would both be, he's like 60 miles an hour, so I would assume that he didn't like fully read the problem, so he'd set T1 and equals to 1 and T2 equals to 1. Where then it would just be
Oh, okay, I got you.
over 2.
Yeah, right. I guess maybe the better question, okay, then, so that's just an example. So now we get into, if I do 57 examples like that, is that a good, proof or whatever? So don't forget, you guys are studying now to be, not pure mathematicians, but math educators, but you still have some, good background here, right? When we say our average is equal to the distance total divided by the time total, then the distance total is distance 1 plus distance 2, right? And the, I think I'm doing this right here. And the time total is time 1 plus time 2, all right? But then, oh, yeah. So then, with time 1 equaling time 2, correct?
Yeah.
With time 1 equaling time 2, it's distance 1 over distance 2 divided by 2 times 2. Well, 2 times 1, whatever we call it, right?
Yeah.
Well, I'll just say 2 times, I guess. But then, distance equals rate times time. Distance equals rate times time. So D1 is RT, right? So this ends up being what? R1T1 plus R2T2, right? Over 2, and I gotta change my lowercase there, whatever I'm doing, right? And so I'm gonna call that, no, I'll call it T1 though. And then, but T1 equals T2, right? So that equals R1T1 plus R2T2. Oh, notice.
T1.
T1, sorry. Notice, I'm so excited about my conclusion, right? Because notice this. Where'd D go? Right? When D is the same, it ends up canceling out, right? Because when I replace it with R1T1, and then, of course, T1, I mean, that goes out of there and there, right? And then my R average is actually R1 plus R2 over 2. So I just proved it. Yeah. Now, yes, I don't expect you to do that all the time, the students, but if they're not sure, like I just don't want them to memorize, add them two together and be done with it. But you ought to be able to do that. You ought to be able to think, logically about that. Where's the D go? Somewhere I have to add up the D's. But what have we learned in our MATH327 class and your number theory class and modern algebra and linear algebra? You substitute things, right? And to try to get something to cancel, add a well-defined one, be a little tricky, and you just keep on playing until you get something. Here I'm trying to prove, because what do I do from a pedagogical perspective? What do? I might give 5 problems just like that. And do them exactly like Ashley did over there. And I'm waiting for the brilliant kid to say, can I just add them up and divide by? And then I say, yes, you can, and this is why you can. And then problem number 6 is number 2, right? So now let's do number 2. Because now this time you don't get 60, and this is, or 50, and this one is noticeably more challenging and difficult for really anybody. I mean, this is actually one of those famous kind of Ask Marilyn questions, Facebook, because most people will say, oh, just add them up and divide by. So how'd you get 48? Yeah, Cody, go up there and see. Show us what you did.
Whoa. And just erase
Yeah, just erase everything there.
So first we found the distance. So I should have kept there. D equals RT. So we know that we're going the same distance and our rate. When me and Ryan did this, we just chose a distance to simplify things.
Okay, because you can't really figure it out, right?
Yeah, it doesn't give us specific.
It gives the distance, right?
So we said
It just says at a certain distance, right?
60 miles is equal to 60 miles per hour times t. Our t is 1 in terms of hours. And then for the second one, we did the same thing, and we got
Wait a second. Oh, so you just let your distance be 60?
60 miles.
Okay.
Just because it works nicely with
Right.
60 and 40.
I mean, the weird thing about this problem is the first problem you're given 2 pieces of information.
Mhm. This one.
This problem you're not giving any, and you might say, well, yeah, but this one here you're given distances are equal.
Yeah.
Well, the other one you're given times are equal, right? But it's actually given in the problem. All right.
And then we kept the same 60 distance.
Because it has to be, right?
And then your speed is 45t. Now t is equal to 1.5.
Okay.
And then
Because average rate is always, right, your total distance divided by your total time. I mean, think about calculus. I know you spent all this time finding the derivative at a certain point, the instantaneous rate. But when I teach calculus, I start out saying, what's the average rate of change from the beginning of this function to the end of this function? And you just take the distance, okay, the distance on the y divided by the distance on the x. And then you narrow it down to that. You just have a question.
Why is it 45?
Because
Oh, yeah,
oh,
40 should be 40.
That's what
Yeah, that'll be 1.5 though.
Yeah. But then what I did was a little different from what Ryan did because I just wanted to work it out differently. So these, I should put these in terms of minutes because that's what I did. So this was 60 minutes. This was 90. This is 1.5 hours. What I did was, like when you find an average, I was thinking of it in terms of just when you find an average, you add up the parts and then divide by how many there
Yeah.
were. So I noticed that there were 60 and 90, both were parts of 30, and I took 60, 60, 40, 40,
Wait.
40. Because there's 5 parts of 30. 2 parts of 30 there, 3 parts of 30 there.
Okay.
Yeah, I know.
I'm still not necessarily sure why you split that up into minutes, but that's fine. So
Yeah,
wait,
it
go ahead
worked,
what you did. Let me
it
see what
worked
you
with,
did.
I think you could do it with just hours.
You're gonna have a hard time sometimes teaching because you have some whacked out ways sometimes of following.
Well, that was just for this, because me and Ryan did solve this like the correct way.
Right.
Well,
and that's fine because I think people should see how other ways, and then you kind of suck it into some standard way. But go ahead.
Yeah, and then this is 240. And then there's 5 parts, so you divide by 5.
And there's 5 parts. Wait, hold on. Everybody understand that though? I'm trying to figure out. Go back to the. What was your logic again about the 60s being parts of 30? I'm just confused.
Well, there's 2 groups of 30 there and 2 groups of 30 there.
Wait, what is that number? 90, right? Okay,
90.
so two groups of 30 and 3 groups of 30, right? But where's the 60, 60, 40, 40, 40?
Because
because
you're
I put the
traveling,
60s and
those are your
40s.
speeds.
Those are your R's.
Oh, because okay,
Yeah,
you just
yeah,
didn't
yeah.
write a D over T kind of thing.
Yeah.
I gotcha.
Sorry.
So
So you were going, for 30 minutes you were going 60 miles per hour,
So you get
30 minutes you were going 60 miles per hour, 30 minutes you were going 40, 30 minutes you were going
yeah, but
40,
crap,
30
why
minutes
didn't you
were
just
going
take the 60 and the 40? I mean, I would have kept them as miles per hour, in hours.
Hours,
But
yeah.
why didn't you just take the distance, which was 60 and 60,
Yeah.
and divide by time? Which would, yeah, right, you
I
should
just
have done
think
that.
about it
Yeah, I
differently.
got
That's what I did.
Okay.
Yeah,
I took
because
60 and 60, added up to get 120, and I took.
Okay, now why did you stop there and say then the answer is 48? Did you do anything else?
no, so that's
Alright, then I have a question. Does anybody else have my same question? Well, what if the distances were 300?
Then your T's would be different.
Okay, but would I still get 48? I mean, you just made up, see what you yank 60 out of your behind? And you probably did. No, but my question is, it's a legitimate question because you made up, you added information to the problem.
Well, your T would be, if the distance was 300, T would be 5 here and, oh, an ugly number there.
All right, I'm gonna put you out of your misery and say this: the answer's still gonna be 48.
Yeah.
Okay.
Yeah.
Your job for Thursday is do this and figure out why the heck it's 48.
Okay.
You understand what I'm saying? Figure out why. Well, and I'll even give you one more better. Okay. This right here. This is actually, well, when you add 2 things up and divide by 2, we call that the what?
Average.
Average or arithmetic mean because we added 2 things, right? Do this for me. Take 2 times R1 times R2 and divide by R1 plus R2 and see if you get 48. You will. That right there is another mean. It's called the harmonic mean. So it's still an average. It's just a different type of average than your arithmetic mean. Now what I want you to do is this. What's that?
480 divided by 1.
Yeah. So I want you to do some Math 205, you know, number theory kind of manipulation, and and prove why when the distances are equal. So over here, what did I say? T1 equals T2, right? T1 equals T2. You're going to do something very similar, and you're going to see D1 equals D2. And see if you can't come up with the formula 2 times R1 times R2 over R1 plus R2. Okay? So you have that to do for Thursday, and I want you to go to, I'm not going to have you look at it, we'll look at it in class, but you can go to problem number 25, or problem on 25, and I've given you a little bit of something there. The question is, why can't we simply divide numerators and denominators like we do with multiplication of fractions for division of fractions? Why do we have to invert and multiply? That's the question. In the homework that will be posted, you'll see an actual example. 15 40-seconds divided by 30-sevenths. Why don't you perform that by dividing straight through? So 15 divided by 3, 42 divided by 7, and then invert and multiply, and see if you get the same thing. And then try doing it with 4/5 divided by 2/9 and see if you can make sense of that. And actually, I don't know why number 2 is there, not number 2. I'll fix that before it goes to. Definitely not number 2.
So that homework then can be found on YouTube.
Yeah, I'm just posting those on YouTube. That way you can
Sounds good.
remember that.
Oh,
And then you're gonna have to remember.
plus the stuff. Yeah, like, my whole reasoning behind it was like, in the first problem, you had 2 equal parts of 45. So like, if you broke it up into equal parts in terms of time, probably add them up. Don't do that. Just find the average. Like how we normally find any other average.
Yeah, so
I think, like, if it would have been 1 and 1.5, it would be 1 plus 1 plus 1.5 plus 1.5.
right. No, I see what you're doing there. Yeah, that would be. I don't know if anybody. I mean, this is why I like to give students problems like this, and then have them solve it, you know, or try to solve it in whatever way they want, and then let's talk about their solution methods.